When I'm writing a web app, there's an architecture that I always gravitate to. It's simple yet scalable and fits a wide array of use cases. It involves 3 distinct processes and 1 queue, in addition to whatever data store you want to use. You can reduce the number of moving pieces by using your primary data store as your queue, and I often do this with Postgres. But as for the processes, those are what I want to talk about today. And the 3 processes I like to call server, worker, and cron. Server is responsible for serving your web requests. It's probably the most familiar of these 3 services, and it's what all web frameworks are going to provide for you. It listens for new HTTP requests and returns responses to the browser. You want to keep these web requests as fast as possible for a good user experience. And to do that, you'll often have some work that you don't want to do during the web request, but you do need to make sure happens. A common example is sending an email after signup. We want this to happen, but we don't necessarily want the user to have to wait for this email to be sent to see the next page. And this is where the worker process comes in. This process is responsible for working off a queue of jobs. Each job should define its type and any arguments that are needed to run this job. The worker process sits in a loop looking for new things to be added to the queue and pulls them off one at a time and processes them. I often find it's useful to give jobs a priority and work them off in some way based on their priority, but we can call that an optimization. A first in, first out queue is where I would start if I was building a worker process from scratch, which is exactly what I'm doing for my blog right now. And the final process here is cron. Cron's job is pretty simple. It puts new jobs on the queue based on some schedule. I often have some jobs that run on an interval, like say every hour, and then some jobs that run on a specific schedule, like every morning at 6 a.m. One thing that I really like about this approach is that it horizontally scales really well. Both server and worker can scale horizontally to fit demand. This means we can just take the box that's running that process and just create more processes horizontally to scale out based on the number of requests. So if we have more web requests or more jobs, we can simply spin up more server or worker processes respectively. And importantly, you can scale these 2 processes independently. If you have a lot of web traffic, you might need more server processes, and you can keep your jobs low if you don't have many. And on the flip side, if you have lots of jobs but not very many web requests, you can scale your worker count, your worker processor count. And both of these things also fit with auto-scaling really well. You can auto-scale based on request volume or maybe job volume and figure out the right scaling for each of these 2 processes. Cron is the exception here. You don't really want to naively horizontally scale your cron, or else you'll end up with duplicate jobs in your queue. If you have 2 cron processes that are both supposed to enqueue a job at 6 a.m. and 6 a.m. rolls around, you might end up with 2 of those jobs in your queue. Luckily, cron doesn't usually have too many scaling concerns. It's only responsible for sitting there in a loop and enqueuing jobs on the schedule. So I usually find that a single cron process can scale to as many jobs or as many enqueues as I need. If you really do need to horizontally scale your cron though, you could partition your jobs and assign some to one process and some to another. Another really cool aspect of this 3-pillar approach is that you can create different durability guarantees depending on what you use for your queues and data store. For instance, if you need guarantees about cron jobs definitely being enqueued, you could write the state of your cron process to your favorite data store. When you enqueue a job from your cron, you could write when the last time you enqueued it was. So if your cron is ever down, you can enqueue any jobs that were missed when it comes back online. You can even use a durable store for your queue too, so you don't risk losing jobs. This is one of the reasons I like Postgres queues. They fit in my primary data store, and they give me durable by default jobs. Another thing I really like about this 3-pillar architecture is that these 3 processes are relatively easy to manage and can be applied to just about every project. I've found that basically every web app that I've needed to build fits nicely into this mold and doesn't require any additional infrastructure once you have these 3 pillars set up. My goal with setting up these 3 processes early is that it reduces decision making in the future. If I already have a job queue, it's really easy to take advantage of it. I never have to rely on hacks like sending emails and web requests, since it's really easy to offload those to the worker process. Like I mentioned earlier, I'm currently building out these 3 processes for my site. It's been a lot of fun to stand up these processes from first principles instead of using frameworks. If you want to follow along, be sure to subscribe to my newsletter or check out my Discord. You can find my newsletter at coreyja.com/newsletter, and from my site at coreyja.com, you can also find a link to the Discord. I hope you enjoyed this video and learned a little bit about the architecture I like to use for web apps. I hope you can like this video and subscribe to my channel for more. And if you are really enjoying my content, please head over to my GitHub sponsors page where you can sponsor my work so I can keep making these kind of videos. Thanks, team. Let's keep learning together, and I will see you all online.